This is a nice problem from electrostatics regarding electric field lines. So it states that an electric field line emerges from a positive point charge plus q1 at an angle alpha to the straight line connecting it to a negative point charge negative q2. At what angle beta will the field line enter the charge negative q2? So here is the positive charge and here is the negative charge. So this straight line joining them, and here one of the electric field lines emerges from positive charge q1 and this is negative charge q2. This q2 is negative, by the way, and this angle is alpha. So this electric field line is going to enter negative charge q2 at some angle not necessarily equal to beta. When alpha is equal to beta, in this case q1 is going to be equal to q2, but if q1 and q2 are different, then alpha and beta won't be same. So here we have to find out beta in terms of alpha, q1 and q2. How will you find it out? So in order to find it out, we can think of electric flux. So if we consider a surface envelope and symmetrically, let's say this angle is also alpha and beta. So this surface envelope in 3 dimension is going to cover up all the electric field lines within the envelope, right? So this is our situation, and if we take any cross section here, we can say that electric flux through any cross section is going to remain same, because number of electric field lines through all these cross sections will be same, right? So all these cross sections will be same. Now let's consider one of the cross sections very near to q1. So let's say this is very near to q1, and we say that okay, if it is very near to q1, so we can say this is going to be a cone. This is going to be a cone nearly, because this will be straight line if this cross section is very close to q1. So we can say, I'm zooming it out. So this cone is forming an angle of alpha. This apex angle is semi-apex angle is alpha. So point charge q1 is here. So we have to find flux of the electric field due to charge q1 and q2 through this surface, through this cross section. And here, by the way, is q2, which is very far away from this cross section. So we can say this angle is going to be nearly 0 degree, right? Fine. So now we can use one other formula. Actually, we will derive it later on in a video, that if a point charge q is here and it forms an angle of theta, so electric flux through this cross section can be written as q over 2 epsilon naught times 1 minus cos theta. So using this formula, we can write net electric flux through this cross section. Through this cross section, net electric flux is going to be q1 over 2 epsilon naught times 1 minus cos of theta. In place of theta, we can put alpha plus q2 over 2 epsilon naught, and by the way, this is negative q2. So q2 over 2 epsilon naught into 1 minus cos of theta is 0 degree here. And by the way, since it is negative, so positive sign will be there, because electric field due to this is going to be in the same direction. It won't oppose the electric field due to negative q2 through this surface. So q1 over 2 epsilon naught times 1 minus cos alpha plus q2 over 2 epsilon naught times 1 minus cos 0 degree is going to be equal to, now we have to consider another cross section, this cross section very close to q2. Then in that case we can write in the similar fashion, it will be q2 over 2 epsilon naught times 1 minus cos of beta in place of theta plus q1 over 2 epsilon naught times 1 minus cos of, again it will be 0 degree, because if we consider a cross section very close to q2, this negative q2, and again q1 is here, so this angle is going to be nearly 0 degree, and this angle, by the way, is beta. So this is nothing but the flux continuity equation, because electric flux once again will remain same for all the cross sections. The cross section which is very close to q1, electric flux through it is this one, and electric flux through the cross section very close to q2 is this one, and both are equal. Now we can also see that this is going to be 0 because cos 0 is 1, and this similarly is also going to be 0. So we have q1 over 2 epsilon naught times 1 minus cos of alpha is equal to q2 over 2 epsilon naught times 1 minus cos of beta, and this can also be written as 2 epsilon naught gets cancelled, and q1 times 1 minus cos alpha, according to trigonometry, that is 2 sine square alpha over 2 is equal to q2 times 2 sine square beta over 2, and once again this 2 gets cancelled, so from this we can find our sine beta by 2 is equal to sine of alpha over 2 root over q1 over q2, and from here we can also find as beta is equal to inverse of sine alpha over 2 root q1 over q2, and since it is beta by 2 we have this 2 here, and this is the final answer. Oops, this is our final answer. Hope you understand it. Thank you very much.